Okay, this is a little bit different engine, and I wanted to show you this engine simply because one of the more popular cars to work on nowadays that a lot of seems to be pretty popular in this area are Subarus. Subarus have a similar engine. The difference is Subarus are water cooled. This one happens to be an air cooled engine. So we'll just do a quick walk around on this car. This is out of a Volkswagen. This is a Type 4 engine, so it would go in like a Vanagon or a bus or something like that. And this right here is going to be your valve cover, and this silver part right here is going to be your cylinder head. These pieces right here, these round pieces, there's 4 of them. There's 2 here, there's 2 here. These are going to be your cylinders. That's where your pistons are at. Pistons are inside here. And if you notice the fins on this engine, you can see the fins right here on the cylinder head. You can see them on the cylinders. This is how the engine dissipates heat, is with these cooling fins. So air is forced across these cooling fins, which dissipates the heat, so it doesn't have antifreeze, it doesn't have a water pump, and so that's the way these engines are cooled. When these engines are fully assembled in the car, they've got tin that fits very closely around here that channels the air across these fins so that everything cools the way it's supposed to. You see the spark plugs here. Now this is an older engine, so it's going to be run on a carburetor, or run with a carburetor, and so it's also going to have low energy ignition on the spark plugs. These spark plugs usually generate about 15 to 20,000 volts, whereas on a more modern engine you'll have upwards of 60,000 volts on the engine, or I mean on the spark plugs. Now this big round thing right here, this is the flywheel. On a manual transmission, or in other words, a transmission you have to shift yourself, these are usually made out of pretty heavy steel, and they actually act as kind of a flywheel or a centrifugal force to help the engine keep moving around. Once you get that mass spinning, it uses a centrifugal force to kind of help the engine to stay spinning. And so this is called a flywheel. And you can't really see it very well in here, but there's a machined surface right inside here where the clutch rides, and so you can disengage the transmission and shift gears if you want to on this. These teeth along here, this is where your starter motor engages so that you can spin the engine and get it started. Over here on this side, now this is called a pancake cylinder, or pancake engine, which means that or an opposed cylinder engine, which means that the pistons are on the side like this, so they kind of go off to the side. You got 4 cylinders, 2, 3, 4, and you can see the spark plugs here, cylinder head. This is going to be your intake manifold or intake port right here, and your exhaust ports are going to be down. Let me get underneath here so you can see. The exhaust ports are right down here.
Yep, right here.
Right there. That's where your exhaust ports are. The tubes that you saw down underneath there, that's where your push rods run, which actually operate the valves inside here. And we'll show you a little bit more in detail on those as we disassemble. This right here is going to be your oil cooler, and if you see here's your oil filter. So if you're going to change the oil on this car, that's where you'd change the oil filter. Here's your oil cooler. This helps cool the oil and helps the engine stay cool as well. And then over here, like I mentioned, you have a coil that's going to be mounted on a bracket somewhere around up in here. And this is an old low energy ignition coil. We talked about ignition systems last week. But this is a low energy ignition coil, which means that this is filled with oil. It's got your 2 coils of wire in there, your primary coil and your secondary coil. Primary coil is going to be hooked up to these 2 terminals here, and your secondary coil is going to come out the top here. This is going to be your high voltage terminal. This is going to be your low voltage terminal here. And so that's the low energy ignition coil. This is another slang term for this, is like a can coil. A lot different than the epoxy resin coils that I was showing you in the video on ignition systems. A couple other unique things about this engine. This little guy right here is the thermostat, and it's got a cable on it. It's filled with some type of, sometimes these are filled with refrigerant, sometimes they might be with wax or bimetals construction. So basically when it gets hot or cold, it expands and contracts kind of like a spring, and it moves this cable, which is going to open up louvers that are on the tin that will allow air to go across the cylinders and cool them. So that's kind of a unique feature on these systems that you don't normally see. Some of the other things that you might want to point out, this right here is going to be your dipstick hole for your dipstick, oil dipstick. This right here is where you're going to fill the oil with. Now, just to get you oriented, the front of the car is going to be this way. So this right here is going to be, this is a rear engine car, so it's going to be sitting in the back of the car. When you lift up the engine cover, this is going to be the first thing you see, and then the front of the car will be that way. So this right here is where you're going to have your cooling fan, which circulates air through the tin and around the engine to keep it cool. This hole right here is going to be where your distributor goes. So remember I showed you a distributor in the ignition section. So the distributor goes in here and it distributes the spark to the different cylinders. This is going to be your crankcase breather. So this allows the crankcase to vent off any built-up pressure inside here from blow-by on the pistons. And we'll talk a little bit more about blow-by and all that kind of stuff in later chapters. But anyway, just to give you an idea, that's what this is. And I think that pretty much covers the air-cooled engine. Okay, we've got the valve cover off on this one, so you can see the components inside here. This right here is going to be your rocker arm assembly. So these are your rocker arms right here, the valves on each one of these. So this is going to be intake valve, that's going to be an exhaust valve. And the way I know that is looking at this valve. If you look right up here, it's right in line with the intake port. This one right here will be right in line with the exhaust port underneath. So that's the valves on this side here. To adjust these valves, remember the valve adjusting video, here's your jam nut and here's your screw right here to loosen that and adjust it, and you would put the feeler gauge in between the valve and the rocker arm assembly. On this side we have the cylinder head off, so you can see the pistons that are up inside here. A couple of things, I don't know whether you'll be able to see it on the camera or not, but one of the things you want to look for in a cylinder is to see if it still has the cross hatching. And we're going to talk a little bit more about that as we get into the engines. But the cross hatching is when you deglaze a cylinder, you want the cross hatching at about a 45-degree angle, and it should go across the cylinders like that. And so this one here, the push rods that open it up and close the valves are right down here on the bottom. And you've got, these are called barrels, or the cylinder sleeves. These will come out as an assembly when we get a little bit further on in the process. Over here we've got the rocker arms disassembled. So you've got the rocker arms laid out here with the little springs that keep them separated and keep them in place and all that. And here is the cylinder head. So you can see the intake valve, the exhaust valve, and if you look on the bottom side. Now on this particular engine, we had shims that go in here because that this cylinder head has probably been machined before, and to get the right amount of clearance we had to put, there's some shims that are needed right here. And then if you look, we've got intake valve is usually the larger one, the exhaust valve is usually the smaller one. The exhaust valves are the ones that get really hot sometimes, and the intake to let air into the cylinder. So that's the disassembly of the Volkswagen engine. Okay, we're going to pull the valves out of this cylinder head, and what we need to do that is we need to use this valve spring compressor. So the valve spring compressor, the way it works, you can adjust it on this end here with the screw. You can also adjust it on this end with a screw right here so that it fits the top of the valve correctly. And so I'm going to have CJ put that on there, and he'll compress it a little bit. Now when you use this thing, you want to make sure that when you compress it, you compress really slowly and make sure that you're on the top of the valves here. And then you also want to make sure that you're on the valve back here when you go to compress it. And then what I like to do is just compress it just enough where it exposes the keepers. And here's the keeper right here. So pop one keeper out with a magnet, and we'll get the other keeper with the magnet. Okay, both your keepers are out, so then you can release the tension with the valve spring compressor very slowly, so you don't lose your springs and all that kind of happy stuff. And there's your valve springs. And your valve just pops out the bottom side there. It'll pull out the bottom. And there's your exhaust valve. We already removed the intake valve on there. And so that's how you remove valves when the cylinder head is off from the engine. You can actually remove these valve springs with the cylinder head on the engine, but in order to do that, you have to take the spark plug out, put a tool in there, and put compressed air in the cylinder to pressurize the inside, and then you can use a tool to compress the valve spring and take the keepers off that way. But we'll do that in another video. We're going to check the valve free height on the valve springs here. Now the first thing we probably want to do is we want to check and make sure that our bench is actually level. And so this is actually a straight edge. This isn't just a ruler that you buy at Home Depot, but it's actually got a machined edge on it. And so it is a precision tool that has a cover that goes on it when it's not in use. And what we're going to do is we're going to check and make sure that the bench actually is straight. And you can see where the bench is not actually straight. We got a low spot right there. And then we're pretty good over here. So we've got a low spot right here. And so you're going to see when we do the measurement here that that's going to show up when we measure the springs. So to measure the free height on the springs, what we want to do is make sure that all the springs are in the same orientation. So you see the edge of the spring right here, right there, right there, right there. So I've got them all pretty much the same. We're going to set this straight edge on top of the valve springs, and very gently we're going to try and fit a feeler gauge underneath. And see how it fits underneath that one there? No problem there. But if you remember, we had a low spot in the table right there. So these springs are probably going to be okay because they're brand new, actually. And so this is the way you would just measure each one of those valve springs to make sure that they're all approximately the same. Now, according to the specifications on this particular engine, if you have 0.1 difference between them, then that spring needs to be replaced. And this is a 10 thousandths feeler gauge that I've got right now, so this is 0.01. And that's as much as I could get in here, and that's even with a warped bench. So these springs are just fine. There's no cause to worry about replacing these springs. The other thing I wanted to mention that I don't think I mentioned when we disassembled is the valves need to go back in the same place on the cylinder head. The springs need to stay with the valve. Some people may argue on that. I've heard other people in the industry say it doesn't really matter, but trust me, it probably does, so better safe than sorry. So make sure that when you disassemble all these things that the valve keepers and the valves and the springs all stay oriented with the same cylinder head and the same hole that they all go in. So we've got this organized right now so that we've got all the keepers right here, all the valves in the same place, so that when we reassemble, the valves and the keepers and everything are going to go back in the same place that they came out of. One of the other things that you need to check on a valve spring, which we don't have the correct tool to do it, so I've just got to show you on the whiteboard here, is you're going to take the valve spring itself and you want to make sure that it's square. So you've got a machinist square here. This is not a carpentry square that you'd buy at Home Depot. It has to be one that's very close tolerance. And you would set the valve spring right up there and make sure that it's square along this side and along this side. Just kind of rotate the spring around and make sure that it's square all the way around. And that's checking the spring for squareness. The other thing I wanted to point out is the valve guides. These are little brass or bronze inserts that go in the cylinder head. So when the valve comes up through there, these guides are what seals the oil from going down in and getting burned in the combustion chamber. These are replaceable, so if you have oil consumption issues with the cylinder head, you can replace these valve guides. And there is a procedure for actually measuring the valve guides, which we'll cover after we cover measuring tools. So, but anyway, that's what it looks like from the top side. So let's roll the engine or the cylinder head over. You can see that this is on the bottom side. Now the valves go in the cylinders just like that. And what we're going to look at now is we're going to look at the valve seat. We're going to look at the valve seats now. The valve seat is right here on the underside of the valve where the valve actually seals to the head. So this is the exhaust valve right here. This is called the valve face. So we've got the valve face right here, and this is the valve seat. And so we want to check to make sure that those match up and that they seal really well. And so what I'm going to do is I'm going to have CJ, he's going to be our Vanna White today, and just going to mark the seat of the valve with some type of a marker. Sharpie works good. These dry erase markers work really good. So just put a couple hash marks on there, and then what we're going to do is we're going to install it in, or we're just going to slide it into the cylinder head, and we're going to tap it a few times. So just tap it in and out, and then maybe twist it a little bit, and then we're going to take it out and we'll be able to see where the valve seat and the valve face are matching up. So if we look at that, you see how the marks are almost gone? So it's matching up right about in the middle of the valve face. So it's like right about here is where your matching seat is. So that's a really good valve grind on this one. So you want to make sure that it seats all the way around, so all those hash marks are all cut. They're all good. Now if you notice on the exhaust valve, it hits like right in the middle of the valve, and that's about where you want it to hit. The intake valve, we'll do the same thing on the intake valve, and you'll see that it hits more on the edge of the intake. The reason it does that is because the intake valve usually runs a little bit cooler than the exhaust valve does. And the exhaust valve, we need to dissipate some of that heat, so we need to get that transfer a little closer up into the middle of the valve face rather than down towards the edge. Okay, if you see right here is where our valve is actually contacting the valve face is contacting the seat is down here at the edge, which is about right for an intake valve. So these valves look really good, which we expected because this is a rebuilt cylinder head. So it looks like whoever put this together did a really good job in getting the valves ground to the right way. Now, if we needed to adjust these valves, so say these seats aren't working properly or they're not hitting properly, there is a way that we can adjust that using a valve grinding or valve lapping compound. So I'm going to get CJ to hold the camera here, and I'll show you how that's done. So what the valve lapping compound, basically what it is it's just a really fine gritty paste that you can buy this stuff at any hardware store. It comes in really handy for a lot of different purposes, but it comes in different thick or different grittiness. So you can get real coarse, you can get really fine, whatever you need to do. But anyway, you take this valve grinding compound, and what you do is you rub it on the face of your valve. So you rub the valve grinding compound on the face of the valve, and then you install it into the cylinder head. We're not going to actually lap these valves because they're brand new and they're really good, so we don't want to mess them up. And then once you have the valve grinding or the valve lapping compound in here, what we're going to do is we're going to stick the valve lapping tool on here. Okay, we're going to do the intake because the exhaust one wasn't one to stick very well. Basically what you're going to do is you're going to suction cup this tool on the bottom side of the valve, and you're with the valve lapping compound in here, and then basically what we're going to do is we're just going to spin it like this. And it doesn't take a lot of pressure, but you just spin it like this a little bit and then recheck the valve seat with your marker again. Clean everything off and recheck it and make sure that it's seating where you want it to seat. If you can't get it lapped in with this lapping compound, what you may have to do is actually grind it on a valve grinding machine, which is something that we don't have here at the college. You'd have to take that to a machine shop and have it done.